Yes, I can see a screen.
Okay, all right, good. Okay, so this is the one we said we'll start with, right? Then we'll now go and look, see if we would find the ones for the curved graph. Okay, so we'll just take a few of these and then we'll switch and see if we can find curved graph. All right, so can you take a look at this question carefully? It says change 3 inches to centimeters. So which of the lines represents the line for 3 inches?
Um,
What's the color?
the one that represents the lion, is it the green? Oh wait, change. Wait, is it the green one?
So
Pardon?
you can, yes, you're correct. It is. It is. So you can see where does the green line meet the graph, and then let's trace it to the y-axis. So now, if you look at the y-axis carefully, can you tell what the scale is? The centimeter axis. Can you tell what the scale is? Because it looks like we
Um,
have 10 boxes
wait,
before between 0 and 4.
is scale the numbers on the outside?
This one, let me annotate so you see what I'm talking about. This side, can you here like this, like this. Can you see where I annotated in red at the
Yeah.
bottom? Two? Can you see? Let's try and see if we can figure out the scale of the graph because it's based on that scale that you'll be able to get the value of what of where that green line meets the y-axis. That's the centimeter axis. Okay, so this conversion graph is converting centimeter to inches, I think. Yes, this can convert centimeter to inches and vice versa, inches to centimeter. So let's establish the scale. Can you figure out the scale? The same method I taught you back then. Look at the scale. Between 0 and 4, how many small squares do we have?
Mm. Oh, wait. So what's the red line for again?
Which red line? The one that comes after the green line. Are you referring to the red line that comes after
Yeah.
the green? That one we've not come to that one yet. I think that one is for the second question. Let's focus on the green line for now. Okay, Mason, can you hear me?
Yeah.
Okay, I said let's focus on the green line for now. What is the scale on the y-axis? What is the scale on the centimeter axis? Are you trying to calculate it?
Hmm.
Are you trying to calculate the scale on the centimeter axis? Hello,
Yeah.
Mason, can you hear me at all?
Yeah, I can hear you.
Yes, I asked a question. Are you trying to calculate the scale? I need you to calculate the scale on the
Yeah.
centimeter axis.
Yeah. 4, 2. So is going up in twos and there's 1, 2. Wait, do you to find the scale, do you have to do two time two, is it divided?
Yes, that was the method I told you. I told you let's try and figure out how many squares are between, the 2 points.
Oh, there's five between a 1 point. There's five going up. So it's 1, 2, 3, 4, 5, and then it's two. So wait, could that mean that? Oh, never mind. Sorry, never mind.
No, if you are sure about it, let's, you might be right. Okay. So if you look at the graph very well, right, where
Mm,
where I just annotated now, okay, is zero, right?
mm-hmm.
After the first five squares, I have two, isn't it?
Yeah.
After another five squares, I have two again, making four. Excuse me,
Mm-hmm.
right? Okay. So what that should tell me is that I can divide two by five to find out what is the value of one of those squares. Okay.
Yeah.
So
Yeah.
divided by five squares. Okay, not five squared though. I'm just writing the squares there to tell you what the five is. The two is the value, and the five is the number of squares. Okay, so let me write it here. So um when you want to calculate the scale, it will be easy for you to know. Because if you don't know the scale, there's no way you would know the value that lines up on the y-axis. So 2 divided by 5, let's confirm that by just doing a quick small division here. 2 divided by 5 means 5 into 2, and you have 0 point. Okay, now I don't know which method of long division you are taught, but this is the method I know. 5 into 2 is 0 point. Then you now put a 0 here. That'll make it 5 into 20, which is 4. And 4 times 5 will give me 20. Uh, 20 minus 20, the remainder is 0, right? And that's what you have. Can you see this method? Is this the method that you're familiar with?
I think yeah.
Okay, good. So that means each square is 0.4. That's the implication. Each single square is what? 0.4. And that now means that if I now want to get the place, which this is the place that it cuts off on the y-axis, just somewhere before 8, then, and each square is 0.4. So that means 6 is here. The good enough, they help us to create 6. So the after 6, I have 6.4. That's the next square. 6.8. That's the next square. 6.8 plus point 4 is going to be 8 plus 4 is 12, right? That's
Mm-hmm.
7.2. So 7.2 is slightly above 7.2, which I think, I don't know, maybe because of the way they build the line, they want us to uh, uh, probably go with 7.4 as the value. So that's the reason why they have 7.4 as their. So I think it's even really there, right? Between 7.4 and, oh, yeah, 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 yeah. Yeah. Wait, let me count it again. Let me count it again. I have to be careful now because it's kind of looking tiny. So 6.2, 6.4, 6.8, 6.8 plus 0.4 is 7.2. 7.2 plus 0.4 is 7.6. Okay, so I think that's it. So it's actually between 7.2 and 7.6. Okay,
Mm.
so I don't know why they said between 7.4 and 7.6. I guess probably their own, they were trying to be more precise in terms of the actual value. But anyway, I think if you allow for an error margin of say plus or minus 0.5, we would still be correct. So, do you can you see why it's 7.4 in this question for
Yeah.
three inches? Okay, all right. So let's look at the red line. Okay, the red line is for the second question where it says change 50 cm. Oh, hold it. Change 50 cm to inches. Now, I want you to look at this graph very well. Do you have 50 cm on the graph?
No.
So, what did I say you should do whenever you have questions like this?
Is it you could wait, could you like so you could do so since 20 cm is 8 inches, could you do 20? Could you do 20 twice for 40? So that would be 16. And then you could find 10, which is in between 8 and 12. And then
No, 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 no. If you follow that method, you might mess it up. Okay, so okay, 20. Okay, okay, let's see. Though I proposed another method, but let's see your method. Okay, so you said let's do 20. Yeah, okay, go ahead.
so and then when you find 10 is 4 inches. So then when you add 20 twice, so 20 twice is 16,
Yeah, it's
and then
16.
plus 10.
Okay.
So that makes it 50 centimeters plus the 4 is 20 inches.
Oh, okay. Okay, that's fine. That's fine. I like that method. That's cool.
Mm, good.
Okay. Yeah, it's okay. That's fine. If that if that gives you a correct answer, which lines up with what they did here, it's perfect with me. It's okay. I like that method too, because it somehow helps you to be able to figure it out. Okay.
Yeah.
Let me see. I'll save that. Okay. All right. Okay.
Mhm.
All right. Let's go to the next question. Let me erase and go to the next question. Okay. Next question looks something like this. Okay. Can you see the next question?
Mhm.
Okay. So this question converts, it changes liters to pins. So let's see what they want us to do here. It says 15 liters to pins. Okay, so liters is the x-axis, that's the horizontal axis, while pins is y-axis, which is vertical axis. So 15 liters would be what? If you place 15 liters to the line, what do you have?
Mhm. Uh, wait, what, can you please repeat that?
Okay, okay. Can you see this graph clearly?
Yes.
So if you zoom in, you might be able to see it better. So I said this graph converts the liters to pins. So I now ask, according to the question, we want to know how many pins there are in 15 liters. So um what would that be? If you place 15 to the graph, what would you have?
So if you followed the graph, so if you were to go to 15 and draw a line up, to where the 15 connects to the line going across the chart,
Yes.
it would be so what you would I think first what you would have to do
Mhm.
is find out how much one space is. So I think on from zero, so going up, I think from zero is 2.5 and then 5 and then 7.5 and then plus 2.5. So and then there's one, two, three, four, five. Would you do what's that thing called? Would you do 0.5
Yes.
divided by 2.5?
So what I would do, right? I would actually do now, following the method I just showed you. I would do 5 divided by 10 because I
Mm.
can see tens between 0 and 5. So I'll do 5 divided by 10, which will just give me a simple value of 0.5 per each small box.
Mm-hmm.
Okay. So now that you have an idea that it's 0.5 for each small box, go ahead and tell us what value would be there for the green line.
Anyway, so as I was saying, so 2.5. Wait,
So I can
0.5.
just give you guys
Wait, wait,
2.5.
wait. Oh, sorry.
I'm looking at the
0.10.
time, okay, not the
Oh, yeah.
liter, the time axis.
So would that be 0.5? No. Wait,
So the
would each gap
yes,
be 0.5?
yes,
Would
it would.
each
Take a look at it, it would be 0.5 each one.
Yeah, so if you follow the line
Uh,
up until where it connects,
uh,
if you count the tiny squares, so it would go 0, 25.5, 26,
uh,
26.5. So it would
okay,
be between 26. It would be around 26.5.
excellent. Okay. So we're pretty much in business with them because they got 26.4, which is perfectly okay. I mean, for a graph that we are making our deductions from, I think we're pretty good with that. All right. So let's do one, the second exercise. The second question says, what does the second question say? Second question says, change 70 pints to liters. And you can see clearly 70 is not anywhere here. So what would you do for 70 to get 70?
So to get 70,
Mm-hmm.
what I could do is so shy. First, I could
And now,
find out
okay,
um the 30. I could find out the 35
okay,
pints in liters twice because that equals
okay,
to 70. So uh I could go up. So I know that each thing is 0.5. So what I could
okay,
do is I could go to the end, which is 20, and
mm-hmm,
follow up the red line,
okay,
and then so then I can see that's around like 20 there.
yes, good.
See it's around
It's,
20.
it's around 20, okay. So, well, of
And then
course,
if
go ahead.
and
So,
then if
if
I
you,
was to follow it,
uh,
I could see that 20 liters twice, which is 40, equals to
Seven.
70 pints. So I think
Oh,
it's 70 pints converted into liters is 40 liters,
that's
I
it.
think.
Okay. We're in business too because it's pretty close. 39.5 was their answer. And that's fine. Like I said, there's always an allowance for what? An uh, um, error range of 0.5. So if you don't exceed 0.5 error range, you are definitely correct, even with your answer. So that's fine. Um, okay, okay, yeah, yeah.
Yeah.
Okay. So I think we've gotten some practice on these. Let's go look for the ones that are called and see if we will by any chance find questions on those. Let me go back to where we can think. Okay. So what would we be searching for? Um, conversion of conversion graphs. Okay. Conversion curve graphs. I don't even know how we put it. I think it's better to put it down here. Conversion curve graph. Okay. Are you still there, Mason?
Yeah.
Okay. All right. Okay. Conversion curves. Okay. So help me. Mason, can you still hear me?
Yes.
Okay. All right. So let's keep looking. We might see. We might see. Might see the one that tells us the curve graphs. I don't see curve graphs in this, but do you see anything that looks familiar?
No, really.
Okay. Were these similar to what you found when you were checking on Genie before we started?
Pardon.
Were
I'm not
they
sure.
transformation? This one is talking about transforming graphs.
Uh, I think so.
Okay. Hmm. Hmm.
I'm not sure.
Okay.
Yeah.
Okay. Let me see. Um, the topics, right? The topics are usually in your scheme of work for the term, right?
Yeah.
Okay. When do you think you'll be able to have access to those?
Got access to um I'm not sure.
Would you be able to get it at school when you go tomorrow?
I think so.
Okay, so I would like you to make some effort, right? So you don't forget. Do you think you can write it down somewhere so that immediately you open your book, you get to see where you wrote it down. Even if you forgot it, you will remember to actually uh, look for it at school and probably write it down in another book that you would bring home so that we can take a look at it probably by tomorrow or Friday, depending on which one is closer to your test.
Mm.
Would that be okay?
Sure.
Okay, so you promised me you would make some effort. You want to write it down somewhere that you would definitely see it once you get to school. Probably the first book you'd make use of at school. Write it down somewhere or a piece of paper and put it in your bag or something so that as soon as you get to school, the first thing you see is going to be what you wrote down so that you don't forget. Can you
Okay.
do that?
So I should go to school and find out the
Yes, the exact topic, right?
okay.
For for the curves, the ones that are the curves. So we'll be able to get the exact um questions on that because it looks like we were able to get the exact questions for the what do you call them? The linear graphs, right? But somehow
Yeah.
the curved graphs, I'm seeing questions here, but they don't look like the ones that you said you guys did in class, right?
Mm.
So that we would not be doing something different from what is expected from you.
Okay.
All right, so I will check in with you tomorrow to see if you were able to get it, and
Okay.
then we'll know if we can have the class tomorrow and just tidy things up, possibly before Friday.
Okay.
All right. Okay, so let me see. Would you be by any chance needing the PDF that we just looked at?
Yeah, sure, sure.
Okay, so let me go back because I think we searched, what did we use to search? Conversion graphs. Um, okay, conversion and units. Okay, I think it was conversion and units. Okay, no, it's not conversion and units. I think it was conversion. Let me just use the conversion graphs that I've been using to search.
Uh,
Just give me a minute. Okay, graphs. Okay, all right, nice. I think this was it. Let's go for that first one. Okay. Okay, yes. This was the question. All right, so I'll download it and send it to you via WhatsApp.
all right.
Okay. All right, so possibly we'll get to know. I'll check in on you tomorrow to know if we can, if you were able to do it, and then we can have a class,
All
schedule a
right.
class. And that class will be at about I think 6 o'clock your time, right? You'll be back from school by 6 o'clock your time.
Yeah.
Okay. All right. So enjoy the rest of your evening.
Thank you, Uncle.
Okay.
Bye.
Yeah, bye.